Hello, friend. Welcome to Science for Sleep. Tonight, we'll be spending some time with snow. Not snow as weather to be endured or measured, but snow as something quietly astonishing. Something that drifts down without urgency, settles without sound, and changes familiar places into something softer and slower. Streets look different under snow. Trees seem to hold still. Even light behaves differently, scattering gently instead of reflecting sharply. Snow has a way of lowering the pace of the world without asking permission. At its simplest, snow is frozen water. Tiny crystals formed high in cold clouds where temperatures remain below freezing. But even that simple description doesn't fully capture what happens when snow appears. Because what reaches the ground is never just frozen rain. It arrives as structure, as pattern, as shape. Each snowflake begins as a microscopic particle, often a grain of dust or pollen, suspended in a cloud. Water vapor collects around it, freezing directly into ice without becoming liquid first. This process is called deposition. As the crystal grows, it moves through different layers of air, each with slightly different temperatures and humidity levels. Those changing conditions guide how the crystal branches, splits, and grows. This is where the quiet mystery begins. You may have heard the idea that no two snowflakes are alike. It's a phrase repeated often, sometimes treated as absolute truth, sometimes dismissed as exaggeration. The reality is softer and more interesting than either extreme. Snowflakes follow physical rules. They are not random. And yet, the exact path each one takes through the atmosphere is so specific, so sensitive to tiny changes, that two identical snowflakes forming in nature is extraordinarily unlikely. Not impossible in theory, but vanishingly rare in practice. The result is an endless variety of six-sided forms: plates, needles, columns, delicate branching stars, shapes that grow outward in symmetry, responding moment by moment to the invisible environment around them. The air itself becomes a quiet sculptor. What makes this especially rare is where it happens. Earth is one of the very few places in the known universe where snow can exist as we experience it. Snow requires a narrow balance. Temperatures cold enough for ice, but not so cold that water vapor cannot move. An atmosphere thick enough to hold clouds. Gravity gentle enough to allow slow descent. Liquid water present somewhere in the system. Many planets have ice, some have clouds, but the precise combination that allows falling snow is uncommon. Snow is not just frozen water. It is frozen water behaving slowly. When it reaches the ground, snow changes how sound moves. Fresh snow absorbs vibrations, dampening echoes and softening noise. This is why snowy nights often feel quieter. Even familiar places seem muted, as if wrapped in fabric. Light, too, scatters across snow's surface. The world appears flatter, calmer, less demanding of attention. These physical changes affect perception. Less contrast, fewer sharp sounds, reduced visual detail. The environment becomes simpler without becoming empty. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is, Snow also moves differently than rain because snowflakes are not compact spheres. They fall slowly, drifting and rotating as air passes through their branches. A typical snowflake may fall at only 1 to 2 meters per second. This gives it time to respond to every subtle shift in air current along the way. Two flakes forming side by side can quickly diverge, simply because the air itself is never perfectly still. The result is individuality without intention. There is no memory in the crystal, no decision-making, just physics unfolding gently, step by step. Shape emerging from condition, pattern forming from motion. And yet, when you look closely, snowflakes often resemble one another. 6 arms, repeating angles, familiar symmetry. This is because ice crystals grow according to the molecular structure of water itself. Water molecules bond in a way that naturally forms hexagonal patterns. The sameness comes from chemistry. The difference comes from environment. Sameness and difference coexisting quietly. As snow accumulates, individual flakes disappear into something larger. Patterns blur. Texture replaces detail. The ground becomes continuous rather than specific. Snow shows how individuality can exist briefly and then dissolve without loss. Throughout this exploration, we'll stay close to that idea. Snow as process. Snow as condition. Snow as something shaped by invisible forces, arriving gently, altering the world without noise or urgency. For now, we begin simply, with cold air holding moisture, with clouds forming quietly overhead, with tiny crystals starting their slow descent. I'm glad you're here. High above the place where snow is eventually noticed, the air holds a quieter beginning. Inside a cold cloud, movement slows until it is almost unrecognizable. Water exists here not as droplets, but as vapor, spread thinly through the air, drifting between invisible boundaries. Within this space, the process that becomes snow begins without announcement. A single microscopic particle moves with the air. It may be a fragment of dust, a grain of pollen, or a trace of mineral lifted long ago from the ground. It is not special in appearance, and it does not direct what follows. It simply exists, suspended, providing a surface where something else can begin. Around this particle, water vapor encounters temperatures low enough to change behavior, shifting from gas directly into solid form. This transition does not pass through liquid. Instead, individual water molecules slow, lose energy, and attach themselves to the particle's surface. One molecule settles, then another. Each attachment is small, precise, and governed by the way water molecules naturally arrange themselves when frozen. The growth is incremental, built molecule by molecule, without momentum or force. As molecules accumulate, a recognizable pattern emerges. Water molecules bond at specific angles determined by their atomic structure. When frozen, these bonds naturally organize into a hexagonal arrangement. This 6-sided symmetry is not chosen, and it is not influenced by the surrounding cloud. It arises inevitably from the shape and behavior of water itself. The forming crystal follows this geometry quietly, extending outward in balanced directions. At this stage, the crystal remains extremely small. It drifts within the cloud, carried by gentle air currents, still surrounded by vapor, Growth continues only when conditions allow it. Temperature and humidity within the cloud are not uniform. Slight variations determine whether additional molecules will attach or remain suspended. When the surrounding air holds enough vapor, molecules continue to settle onto the crystal surface. When it does not, growth pauses. The process does not accelerate. There is no sudden expansion. Instead, the crystal alternates between moments of accumulation and stillness. Each layer forms in response to the local environment at that precise moment. The crystal does not anticipate what comes next. It responds only to what is present, shaped by temperature, moisture, and time. Within the cloud, countless similar processes occur simultaneously. Many crystals begin around many particles, each responding to conditions that are nearly, but not exactly, the same. At this early stage, their forms are remarkably similar. Each follows the same molecular rules, the same six-sided symmetry, the same slow accumulation. Differences have not yet emerged in visible ways. The cloud itself remains calm. There is no turbulence here, only gradual motion. Particles drift past one another without interaction. Ice crystals rotate gently, exposing different surfaces to the surrounding vapor. Growth continues evenly, guided by the unchanging geometry of frozen water. The crystal remains small enough that gravity does not yet assert itself. Nothing in this process requires complexity. It unfolds through repetition, consistency, and restraint. The crystal does not need to grow quickly to become snow. It only needs time and conditions that remain within a narrow range. The environment provides this quietly, allowing formation to proceed without interruption. As the crystal grows, it remains fragile, easily influenced by subtle shifts in temperature and humidity. A slight cooling may encourage additional molecules to settle. A slight warming may slow the process. These changes do not disrupt the crystal. They simply define the pace at which it forms. This early stage carries no visible drama. It is a beginning that does not announce itself, occurring far from where snow is later seen or felt. Yet within this stillness, structure takes shape. Order emerges not from design, but from the natural behavior of water responding to cold air. The crystal continues to drift within the cloud, suspended, incomplete, quietly assembling itself. It has not yet begun its descent. For now, it remains part of the air that holds it, shaped gently by conditions that change slowly enough to allow form to emerge at all. As the crystal continues to form within the cold interior of the cloud, its structure becomes more apparent. What began as a barely detectable accumulation of molecules now extends outward with quiet consistency. Growth does not spread in all directions at once. Instead, it follows a pattern already determined by the way water molecules connect when they freeze. Each molecule of water carries a specific shape, and when temperatures fall low enough for freezing, those shapes align in predictable ways. The bonds between molecules settle into angles that favor a six-sided arrangement. This geometry is not influenced by motion, pressure, or intention. It arises directly from the molecular structure of water itself. As freezing continues, this pattern repeats again and again, producing symmetry without effort. From the center of the crystal, 6 arms begin to extend outward evenly. Each arm grows at the same rate, responding to the same surrounding conditions. When additional molecules attach, They do so in alignment with what is already present. The crystal does not test alternatives. 5-sided or 7-sided forms do not appear. The structure remains consistent, guided by molecular rules that do not change. This symmetry gives the crystal a sense of balance even while it remains very small. Each arm mirrors the others, extending into the cloud with equal restraint. The process does not require coordination. It emerges naturally because every molecule follows the same bonding behavior. Order forms not through control, but through repetition. At this stage, the crystal's growth remains steady and uncomplicated. The surrounding air continues to supply water vapor at a measured pace. Molecules attach along the edges of each arm, reinforcing the hexagonal shape. The crystal rotates slowly as it drifts, but this movement does not disrupt the pattern. No matter how it turns, the structure remains aligned with itself. The predictability of this form contrasts with how snow is often perceived later. Here, variation has not yet appeared. The crystal's symmetry is clear and consistent, shaped by physical law rather than chance. What seems delicate and intricate at larger scales begins as something remarkably ordered. Within the cloud, many crystals follow this same process. Each one forms with 6 arms extending from a central point. Differences have not yet emerged in ways that can be easily observed. At this moment, similarity outweighs variation. The cloud holds numerous crystals, each quietly assembling according to the same principles. This consistency allows growth to continue smoothly. When environmental conditions remain stable, each arm extends at nearly the same rate. No single side advances ahead of the others. The structure maintains balance as it develops, remaining centered and symmetrical as long as conditions permit. The crystal does not require awareness or adjustment. It does not respond to preference or direction. It grows because molecules continue to arrive and attach in the only way they can when frozen. The resulting symmetry is not decorative. It is functional, efficient, and inevitable. As time passes, the hexagonal form becomes more defined. Edges sharpen slightly as layers accumulate. The arms lengthen, still restrained, still even. The crystal remains suspended, incomplete, and quietly consistent. It has not yet encountered conditions that introduce variation. For now, order dominates. This stage of formation establishes a foundation. The 6-sided structure will persist even as conditions change later on. Whatever complexity eventually appears will grow from this symmetry, not replace it. The crystal carries this order forward, shaped by the same molecular behavior that initiated its growth. Within the cloud, the air continues to move slowly. The crystal drifts, rotates, and grows, unchanged in its fundamental design. The repetition of angles and mirrored arms continues without interruption. In this quiet environment, structure remains stable, predictable, and unremarkable in its consistency. The crystal has not yet become a snowflake as it is commonly recognized. It remains a simple form, governed by molecular bonds and steady conditions. But the symmetry it carries will remain with it, preserved through every later stage of its development. As the crystal grows large enough to respond to gravity, it begins to move. The descent is slow, almost imperceptible, guided less by falling than by drifting. Within the cloud, air is layered rather than uniform. temperature and humidity shift subtly from one region to another, forming invisible bands that the crystal passes through one by one. These layers do not announce themselves. They are sensed only through their effects. As the crystal enters an area with slightly higher humidity, additional water vapor becomes available. Molecules settle onto the crystal's edges, extending its form outward. When the air grows drier, this process slows. Growth does not stop permanently. It pauses, waiting for conditions to change again. The crystal rotates gently as it moves, exposing different surfaces to the surrounding air. Each surface responds independently to the conditions it encounters. A small drop in temperature alters how readily molecules attach. A slight increase encourages more rapid accumulation. These changes are measured in fractions of degrees, yet they influence how the crystal develops from moment to moment. Symmetry remains present throughout this process. The 6 arms continue to extend from the center, preserving the hexagonal foundation established earlier. What changes is not the number of arms, but how material gathers along their edges. Where growth resumes, it follows the same molecular rules, yet the timing differs from one arm to another. The environment introduces variation through sequence, not disorder. As the crystal moves downward, it rarely experiences identical conditions for long. Clouds contain gradients rather than uniform zones. Humidity fluctuates. Temperature shifts gradually. Each transition leaves a subtle record in the crystal structure. Growth patterns respond to these changes without anticipation or memory. The crystal does not adapt. It simply continues forming where conditions allow. At times, growth accelerates briefly. At others, it slows to near stillness. These changes do not disrupt the underlying form. They add complexity through layering rather than replacement. The crystal remains coherent, shaped by repeated responses to its surroundings. The air acts not as a force, but as a sculptor through restraint. It determines where growth is possible and where it is not. When the surrounding air cannot supply enough vapor, the crystal's edges remain unchanged. When vapor becomes available again, growth resumes exactly where it left off. There is no correction or smoothing. Each pause and continuation contributes to the developing form. As descent continues, the crystal passes through many such regions. No 2 layers are precisely the same. Differences are subtle, but cumulative. Over time, these variations influence how the crystal's arms develop. Some edges extend slightly more than others. Some regions thicken while others remain thin. The changes are gradual and balanced, guided by the environment rather than chance. Throughout this process, the crystal remains fragile. It responds to the air with precision, shaped by conditions that shift quietly around it. The air does not impose a design. It provides constraints. Within those constraints, growth proceeds naturally, one molecule at a time. This interaction between crystal and air introduces complexity without introducing disorder. Variation emerges because the environment changes, not because the crystal deviates from its structure. The 6-sided symmetry remains intact, serving as a stable framework through which differences can appear. The descent continues, slow and steady. The crystal's form becomes more detailed, yet still restrained. Each alteration reflects a moment of environmental change recorded silently in ice. The air continues to shape the crystal without urgency, guiding its growth through presence rather than force. In this way, the crystal's form becomes a quiet record of the air it has passed through. Not a record of chaos, but of subtle shifts and gradual transitions. The air does not rush the process. It allows the crystal to respond fully to each condition, preserving order while introducing variation. As snow continues to fall, individual crystals often move through the air close together. From a distance, they appear almost interchangeable. Their shapes echo one another, sharing the same six-sided structure, the same general proportions, the same restrained balance. This similarity is not coincidental. It reflects the fact that every snowflake begins under the same physical rules. Each crystal forms from water molecules bonding in predictable ways. The hexagonal structure established early in growth remains present throughout descent. Environmental changes influence how material gathers, but they do not alter the underlying geometry. Because of this, many snowflakes resemble one another closely, especially when viewed without magnification. The idea that every snowflake is entirely unique has circulated for generations, often repeated as a statement of wonder. The reality is quieter and more precise. Snowflakes are not random creations. They are products of consistent molecular behavior interacting with variable conditions. Similar inputs tend to produce similar outcomes. When crystals experience comparable temperatures and humidity levels, their shapes reflect that similarity. For two snowflakes to be perfectly identical, however, they would need to experience the same conditions at every moment of their formation. This would require identical atmospheric paths, matching temperatures, matching humidity, and matching timing throughout their descent. In nature, such exact duplication is extraordinarily unlikely. Clouds are layered, dynamic systems. Even snowflakes falling side by side pass through slightly different regions of air. Because of this, near-identical snowflakes can and do occur. Under controlled laboratory conditions, scientists have observed crystals grown in nearly identical environments that closely resemble one another. In natural clouds, where conditions shift continuously, these near matches become rarer. Differences accumulate slowly, introduced by subtle changes in the air that are impossible to replicate exactly. These differences are not dramatic. They may appear as slight variations along an arm, a thicker region here, a thinner extension there. From a distance, such distinctions are invisible. It is only through close observation that variation becomes apparent. Similarity remains the dominant impression, with difference emerging quietly rather than boldly. This balance between sameness and variation reflects the way natural systems operate more broadly. Rules establish structure. Conditions introduce nuance. Snowflakes follow the same physical laws, yet record their environments through incremental changes. The result is not uniformity, but not chaos either. It is patterned variation, shaped gently by circumstance. Understanding this does not diminish the quiet fascination of snow. It reframes it. The interest lies not in absolute uniqueness, but in the way consistent processes interact with changing environments. Snowflakes do not need to be entirely distinct to be remarkable. Their forms already represent a complex conversation between structure and response. As snow falls, countless crystals carry these small differences downward. They move together, separate, then settle. Once they reach the ground, individual forms quickly lose distinction. Crystals overlap, compress, and blend into a shared surface. The fine details that once differentiated them become less visible as they merge. What remains is the broader pattern. Snow accumulates as a collective, smoothing surfaces and softening outlines. Individual histories give way to continuity. The differences that mattered in formation no longer define the experience of snow once it rests. In this way, the question of whether snowflakes are identical matters most during their formation. During descent and settling, similarity becomes more relevant than difference. The air shapes them subtly, then releases them to a surface where individuality dissolves naturally. Snowflakes are similar because they must be. They are not identical because the environments that shape them are never perfectly repeated. Between these two truths lies the quiet reality of snow. Not a field of infinite uniqueness, nor a mass of sameness, but a gentle balance formed by order responding to change, molecule by molecule, layer by layer. Once a crystal grows large enough to respond consistently to gravity, its movement becomes more noticeable. The descent is not direct. Snowflakes do not fall straight downward in a simple line. Instead, they move slowly, drifting, rotating, and occasionally sliding sideways as they encounter small currents within the air. This slow movement is shaped by form. Snowflakes are light, broad, and irregular. Their extended arms and uneven edges increase resistance as they move through the air. Rather than cutting downward like a raindrop, a snowflake meets the air with many surfaces at once. Each surface interacts with the surrounding flow, reducing speed and encouraging gentle motion. Measured under typical conditions, snowflakes fall at roughly 1 to 2 meters per second. This pace is slow enough that descent becomes an extended process rather than a brief transition. A single snowflake may remain suspended for several minutes, traveling through layers of air that differ subtly in temperature and moisture. As it descends, the snowflake rotates. This rotation is not uniform or predictable. It is guided by small variations in air movement that shift continuously. One side turns toward the air, then another. Each rotation exposes different surfaces to the environment, allowing the crystal to respond gradually to what surrounds it. The shape of the snowflake contributes to this behavior. Irregular edges and branching forms disrupt airflow, preventing smooth acceleration. Instead of gaining speed steadily, the snowflake settles into a slow equilibrium between gravity pulling downward and air resistance pushing upward. The result is lingering motion rather than falling. This extended descent has quiet consequences for formation. The longer a snowflake remains in the air, the more opportunities it has to encounter changing conditions. Slight variations in humidity or temperature influence whether growth continues or pauses along certain edges. The descent itself becomes part of the shaping process, not merely a path toward the ground. Time stretches during this movement. The snowflake is not rushing toward a destination. It remains within the air, responding to each moment as it arrives. Growth may resume briefly, then pause again. The structure adjusts incrementally, guided by exposure rather than intention. snowflakes falling near one another may drift apart or draw closer, depending on local air currents. Their paths cross and diverge gently without collision. Each follows a slightly different route, even when released from similar heights. The air guides them individually, shaping descent through subtle differences rather than force. There is no urgency in this motion. The snowflake does not accelerate suddenly or change direction sharply. Its movement remains smooth, continuous, and restrained. Gravity is present but moderated. Air resistance shapes every moment of descent, ensuring that the process unfolds slowly. As the snowflake continues downward, its surroundings remain quiet and consistent. The cloud thins, air becomes denser, conditions shift gradually rather than abruptly. The snowflake responds without adjustment or awareness, shaped entirely by physical interaction. This slow descent allows form to remain delicate. Rapid falling would distort or break fragile structures. Lingering motion preserves them. The air supports the snowflake long enough for its shape to remain intact, protecting its fine edges through extended suspension. Eventually, the snowflake approaches the lower layers of air. The descent continues, still gentle, still unhurried. The crystal carries with it the accumulated record of its formation, shaped by time spent drifting rather than falling. In this way, snow does not arrive suddenly. It accumulates gradually, one slow descent at a time. Each snowflake contributes to this quiet process, lingering in the air long enough to allow gentleness to define its path. The pace remains unbroken, steady, and soft, guided by resistance as much as gravity, allowing snow to settle only after time has fully passed. As snow reaches the ground, its movement slows further until it comes to rest. The transition from falling to settling is gradual, almost indistinguishable from the descent itself. Snow accumulates layer by layer, covering surfaces without force, conforming to what is already there. Edges soften as fine structures disappear beneath a growing blanket of ice crystals. Fresh snow contains countless small pockets of air trapped between crystals. This structure changes how the environment behaves. Sound waves that travel through the air meet the uneven surface of snow and lose energy as they pass into these spaces. Instead of reflecting outward, sound is absorbed, dispersed quietly within the snow itself. Echoes fade, and sharp noises lose their reach. As accumulation continues, the surface becomes more uniform. Variations in height and texture flatten under the steady addition of snow. Details that once stood out blend into a continuous form. Motion above the surface becomes less noticeable as contrast diminishes. The environment takes on a subdued quality, shaped by coverage rather than alteration. Snow also influences how light moves through the space. Individual crystals scatter incoming light in many directions. Rather than reflecting sharply from distinct surfaces, light spreads evenly across the snow-covered ground. Shadows soften. Brightness becomes diffused. Visual boundaries lose their sharpness as contrast decreases. This scattering effect does not remove light, it redistributes it. The result is an environment where transitions between light and dark become less pronounced. Shapes remain visible, but edges are less defined. The visual field appears calmer, not because anything has disappeared, but because differences are less emphasized. As snow continues to settle, movement becomes less apparent. Objects remain in place, now covered or partially obscured. There is no interruption to this process. Snow does not stop abruptly. It continues to arrive slowly, maintaining the same gentle pace established during descent. The combined effects of sound absorption and light scattering alter how the surroundings are perceived. Sharp distinctions fade. The environment feels quieter, not through absence, but through moderation. Nothing has been removed. Instead, everything has been softened. Snow reduces sound reflection by preventing waves from bouncing freely between surfaces. Without hard boundaries to reflect against, sound dissipates more quickly. The space holds less reverberation. Each sound, if it occurs, resolves sooner than it would otherwise. The surface itself becomes less reflective visually as well. Light striking snow does not return as a single beam. It disperses across countless facets, producing a uniform brightness. This evenness reduces visual strain caused by high contrast. The environment appears steady rather than dynamic. As accumulation continues, snow fills small gaps and depressions. Irregularities in the ground become less visible. The surface smooths naturally, guided by gravity and the settling of crystals. This smoothing process does not erase form entirely. It simplifies it. Nothing in this transformation requires speed. The quieting effect emerges gradually as coverage increases. Each new layer contributes incrementally, reinforcing what came before. The process remains consistent and unhurried. Snow does not impose stillness. It creates conditions where movement and sound become less prominent. The world continues to exist beneath it, unchanged in structure, but altered in expression. The same surfaces remain. The same space persists. Only the way energy moves through it has shifted. As snow rests, it maintains its structure for as long as conditions allow. Air pockets remain intact, continuing to absorb sound. Crystals continue to scatter light. The environment holds this softened state without effort. This quieting is not an event. It is a condition that develops naturally through accumulation. Snow settles, and with it, sharpness gives way to continuity. The environment remains present, but less demanding of attention, shaped gently by countless crystals resting together, forming a surface that absorbs, diffuses, and softens what passes through it. Snow continues to fall within a narrow band of air that surrounds the planet. This layer is thin relative to Earth's size, yet it holds a balance of conditions that allow snow to form and descend in the way it does. Temperature, pressure, and atmospheric density align here within a limited range. Outside of that range, the process changes or does not occur at all. Within this atmospheric window, water vapor can exist long enough in cold clouds to freeze directly into ice. Air pressure is sufficient to support gradual crystal growth rather than rapid condensation. Gravity pulls gently downward, while air resistance remains strong enough to slow descent. These combined factors allow snowflakes to form slowly and remain intact as they fall. The atmosphere does not need to be thick to support this process. It needs to be stable. The presence of layered air, varied humidity, and moderate pressure creates an environment where ice crystals can grow without collapsing or accelerating too quickly. Snow depends on this balance. Too little air, and crystals fall too fast to develop. Too much turbulence and structure breaks apart. Ice exists beyond Earth's atmosphere in many forms. Frozen water is common in cold environments. What is less common is the combination of air and gravity that allows ice to grow slowly while suspended, then descend gently through layers of atmosphere. Snow requires not only cold, but time and resistance. Earth's atmosphere provides this resistance. As snowflakes fall, air pushes back against their surfaces, moderating speed and shaping movement. This interaction preserves delicate structures formed earlier. Without sufficient atmospheric density, this interaction would be brief or absent. Descent would be rapid, and growth would be limited. The thickness of this atmospheric layer is small compared to the planet as a whole. Snow forms and falls within a narrow vertical range where temperatures remain low enough and moisture remains present. Above this range, conditions become too sparse. Below it, temperatures rise and snow changes form. The process occupies a limited space, defined by gradients rather than boundaries. Within this space, countless snowflakes form and descend simultaneously. Each one follows a slightly different path through the atmosphere, yet all remain constrained by the same overall conditions. The environment provides consistency without uniformity. It supports variation without instability. This balance allows snow to accumulate gently rather than arrive abruptly. Crystals form slowly, fall slowly, and settle gradually. The atmosphere does not rush the process. It holds it in suspension long enough for accumulation to feel continuous rather than sudden. The scale of this system remains understated. Snow does not require dramatic forces or extreme conditions. It depends on moderation. Temperatures hover near thresholds. Pressure remains steady. Air density allows resistance without obstruction. These elements combine quietly, supporting a process that unfolds without urgency. As snow continues to fall, the atmosphere remains largely unnoticed. Its presence is inferred through effect rather than observation. It guides motion, moderates speed, and shapes descent without drawing attention to itself. The result is a phenomenon that feels gentle despite its planetary scale. This narrow window persists as long as conditions remain within range. Snow forms, falls, and settles repeatedly, season after season, guided by the same atmospheric balance. The process does not announce its dependence on this system. It simply continues while the environment allows it. Snow remains a local expression of broader conditions. It reflects the way air, temperature, and gravity interact within a limited space around the planet. Without escalation or emphasis, this interaction supports a steady cycle of formation and descent. Within this thin layer of atmosphere, snow continues to fall. Crystals form, drift, and settle, shaped by the quiet stability of the air that surrounds them. The scale expands outward, but the process remains the same. Balanced conditions hold, allowing snow to exist as a slow, sustained response to cold air and gravity, unfolding gently within Earth's narrow atmospheric window. As snow continues to accumulate, the visual character of the surface begins to change. Light no longer meets a collection of varied materials and angles. Instead, it encounters a continuous layer of ice crystals arranged irregularly but evenly across the ground. This surface alters how light behaves, redistributing it rather than reflecting it sharply. Individual snow crystals scatter incoming light in many directions at once. Instead of producing strong reflections or deep shadows, the surface sends light outward diffusely. Bright areas soften. Dark areas lighten. The difference between them narrows. Visual contrast decreases, not because light is reduced, but because it is shared more evenly across the surface. This scattering effect reduces sharp edges. Boundaries that were once defined by abrupt changes in brightness become less distinct. Lines blur gently. Shapes remain present, but they no longer stand apart as clearly from their surroundings. The surface appears smoother, even where the underlying structure has not changed. As contrast lowers, visual complexity decreases. The eye encounters fewer abrupt transitions between light and dark. Fine details require less adjustment to remain visible. The surface presents itself as a unified field, rather than a collection of competing features. This simplification emerges gradually as snow coverage increases. The visual system responds differently in environments with reduced contrast. When differences between areas are subtle, fewer rapid adjustments are required to interpret what is being seen. Attention is not repeatedly drawn from one point to another by strong visual cues. Instead, perception becomes more evenly distributed across the scene. Snow-covered surfaces tend to reflect light upward as well as outward. This reflection further softens the visual field by reducing directional glare. Light does not originate from a single source or angle. It appears to come from many directions at once, filling spaces that might otherwise remain in shadow. As snow continues to settle, the uniformity of the surface increases. Small variations remain, but they are less emphasized. Texture becomes quieter. The environment presents fewer high-contrast signals that would otherwise demand focused interpretation. This does not remove visual information. It changes how it is organized. The scene remains visible, but its features are less sharply separated. The eye encounters continuity more often than division. Shapes emerge slowly rather than abruptly. Over time, the surface becomes increasingly consistent. The accumulation of snow fills depressions and softens elevations, reducing abrupt changes in height that would otherwise create strong shadow lines. The interaction between light and surface becomes more predictable, less demanding of constant adjustment. Visual boundaries still exist, but they are suggested rather than pronounced. The transition from one area to another occurs through gradual change rather than sharp division. The field of view feels expanded, not because more is visible, but because fewer elements compete for attention. This reduction in contrast influences how space is perceived. Depth cues become subtler. Distances appear less segmented. The surface reads as continuous rather than fragmented. The eye moves across it without interruption. As light continues to scatter across the snow, the environment maintains this softened appearance. There are no sudden shifts in brightness. No sharp lines interrupt the field. The surface reflects a stable pattern of illumination, shaped by countless small facets rather than a few dominant ones. Reduced contrast simplifies perception by limiting extremes. Brightness and darkness draw closer together. The visual field settles into a narrower range of variation. This narrowing does not diminish clarity. It alters emphasis, favoring continuity over distinction. The snow-covered surface remains steady as conditions persist. Light continues to scatter. Shadows remain shallow. The environment presents itself without urgency, defined by gentle transitions rather than sharp contrasts. This visual state develops naturally from accumulation. It does not require uniform snow or perfect coverage. It emerges as a result of how snow interacts with light over time. As long as the surface remains covered, contrast stays low and boundaries remain soft. The scene holds this quality without change. Light arrives, disperses, and reflects evenly. Visual complexity remains reduced. The environment offers fewer sharp signals and more continuity, shaped quietly by the reflective and scattering properties of snow, maintaining a consistent, softened field of perception. As snow remains settled across the surface, the environment begins to present fewer changes over time. Movement becomes less frequent. Textures hold steady. The space no longer offers a stream of shifting details. Instead, it maintains a consistent state that unfolds slowly, without interruption. Snow alters how sound moves through the environment. The same structure that absorbs light also affects vibration in the air. Fresh snow dampens environmental noise by preventing sound waves from reflecting freely between surfaces. Vibrations that might otherwise travel outward lose energy as they encounter the uneven, air-filled layers of snow. Sounds resolve more quickly, without lingering. This reduction does not create silence. It changes duration and reach. Sounds, when present, fade sooner. The space does not amplify them or send them back repeatedly. The environment holds less echo, less overlap. Each sound occupies a smaller span of time before dispersing. At the same time, visible motion decreases. Snow-covered surfaces remain unchanged from one moment to the next. There are fewer cues indicating immediate activity. The scene does not continuously update itself through movement or variation. What is seen now is likely to remain similar a moment later. The brain is shaped to prioritize change. Sudden movement, contrast shifts, or unexpected sounds are processed quickly because they signal possible relevance. In environments where change is frequent, attention must remain alert, ready to respond. When change is minimal, the demand for constant monitoring decreases naturally. With snow covering the ground and surrounding surfaces, fewer signals compete for notice. Visual contrast has already narrowed. Sound resolves quickly. Motion remains limited. Each of these factors contributes to an environment that presents less information per unit of time. Lower sensory input reduces vigilance demands. When fewer changes occur, less effort is required to track what is happening. The environment does not prompt repeated reassessment. It remains predictable from moment to moment, allowing perception to remain broad rather than focused. This reduction in signals does not remove awareness. It alters emphasis. Instead of drawing attention towards specific events, the environment supports a more even distribution of perception. The space holds steady, offering continuity rather than interruption. Snow contributes to this state through accumulation rather than action. It does not introduce new stimuli. It covers existing ones, softening their expression. The result is not emptiness, but moderation. The same space exists, but with fewer fluctuations to interpret. As time passes, the scene maintains this reduced level of activity. There are no sudden movements to track, no persistent sounds demanding interpretation. The environment presents itself as stable, consistent, and quiet in its behavior. This consistency changes how information is processed. When input remains steady, the brain shifts away from rapid evaluation. Attention does not need to jump from one change to another. Instead, it remains diffuse, observing without prioritizing. Snow-covered surroundings create this effect by limiting variation. Surfaces look similar from moment to moment. Sounds fade quickly. Motion is sparse. Each factor contributes to an overall reduction in sensory signals. The environment does not ask for engagement. It does not withdraw either. It simply remains present, offering fewer events to respond to. This balance allows perception to settle into a slower rhythm, guided by the absence of urgency rather than its instruction. As snow continues to rest where it has settled, the surroundings maintain this state. Reduced signals persist as long as coverage remains. The space holds steady, shaped by snow's ability to absorb sound, limit motion, and maintain visual consistency. What remains is an environment defined by fewer demands, not through removal, but through restraint. Snow does not silence the world. It simplifies it, allowing perception to encounter fewer changes, fewer signals, and a steadier flow of information over time. Snow continues to fall at a steady pace, unchanged from one moment to the next. The motion is consistent, neither accelerating nor stopping, repeating itself without variation. Each flake follows a similar path downward, drifting gently, then passing out of view. The pattern persists minute after minute without interruption. Repetition alters how information is processed. The brain responds most quickly to novelty, to sudden changes that signal something different from what came before. When the same motion repeats without variation, it no longer requires rapid interpretation. The falling snow offers little that is new. Each movement resembles the last, forming a continuous sequence rather than a series of events. In predictable environments, cognitive load decreases. When patterns remain stable, fewer resources are needed to interpret what is being observed. There is no need to constantly compare one moment to the next, searching for difference. The scene updates itself slowly, with no urgency to reassess. Sustained sameness influences perceptual updating. When input changes only minimally, perception does not refresh as frequently. The environment does not demand constant recalibration. Instead, processing stretches out over longer intervals, responding to continuity rather than interruption. The snowfall provides this continuity through uniform motion. Flakes appear, descend, and disappear at a similar rate. There are no sudden shifts in direction or density. The pace remains even. The visual field presents a rhythm that does not vary, encouraging perception to follow rather than analyze. This slowing does not imply absence of awareness. The snow remains visible. Movement is still present. What changes is the speed at which information is registered and updated. When repetition dominates, processing naturally becomes less granular. Details are noted without being isolated. As snow continues to fall, the environment offers fewer cues that require prioritization. There is no single flake that demands attention more than another. Each follows the same gentle descent. The field of view becomes a continuous flow rather than a collection of discrete moments. Predictability supports this shift. When outcomes are easily anticipated, less effort is spent evaluating them. The brain does not need to prepare for sudden change when none appears likely. Processing aligns with the pace of the environment, slowing to match its steadiness. The uniform motion of falling snow reinforces this alignment. The descent repeats without surprise. The air carries flakes downward in a consistent manner. The pattern remains intact even as individual flakes vary slightly in path or rotation. The overall motion stays the same. Over time, this repetition reduces the need for rapid perceptual updates. The scene does not challenge expectations. It fulfills them consistently. Each moment resembles the one before, allowing perception to extend rather than reset. This effect is cumulative. The longer the pattern persists, the more processing adjusts to its rhythm. The environment does not push for speed. It offers continuity, and perception responds by slowing its internal tempo. Snowfall maintains this pace without intervention. It does not require stillness to produce this effect. Motion continues, but without change. The steadiness itself becomes the defining feature. The absence of sudden variation means fewer triggers for quick evaluation. No abrupt shifts occur to draw focus or demand interpretation. The scene remains open, repetitive, and stable. As flakes continue to descend, the visual system follows their movement without isolating each one. Motion is perceived as a whole rather than as individual events. The field remains consistent, allowing processing to unfold at a measured pace. This slowing is not imposed. It emerges from the interaction between repetition and perception. Predictable environments do not require fast responses. They allow processing to settle into a broader, less reactive mode. Snowfall provides such an environment through its uniform descent. The motion does not stop, but it does not surprise. It continues at the same rate, offering the same pattern again and again. In this setting, perceptual updating stretches across longer intervals. Information arrives steadily without peaks or interruptions. Processing aligns with this steadiness, becoming slower, wider, and less segmented, guided by the unchanging pace of falling snow. As snowfall continues without variation, the field of view becomes evenly filled. No single movement stands apart from another. Each flake enters, drifts, and leaves at a similar pace, contributing to a pattern that does not center on any one point. The scene offers no highlight to follow and no event to anticipate. Attention is naturally drawn toward contrast and motion. Sharp differences in brightness or sudden changes in direction tend to stand out, guiding focus toward what is most distinct. In the absence of these cues, attention behaves differently. When contrast is low and motion is uniform, there is less reason to select one element over another. A uniform snowfall provides this condition. The visual field remains consistent across its span. Flakes are distributed evenly rather than clustered. Motion occurs everywhere at once, but nowhere more than elsewhere. The scene does not organize itself around a focal point. Instead, it presents continuity. Low stimulation environments reduce attentional switching. When there are fewer changes that require interpretation, attention does not need to move rapidly from one location to another. The environment does not prompt repeated shifts in focus. Instead, perception remains open, receiving information without sorting it into priorities. As snow falls in this manner, attention begins to diffuse. Rather than narrowing onto a specific object or path, it spreads across the entire field. No single element claims importance. The scene is perceived as a whole rather than as a collection of parts. Sustained uniform input supports this diffusion. When the same pattern repeats across time and space, attention does not need to reset or reorient. It remains engaged, but without direction. Observation becomes broad rather than targeted. This change does not remove awareness. The snowfall remains visible. Movement continues. What changes is how focus is allocated. Instead of being drawn toward difference, attention rests within sameness. The field does not demand selection. Uniform texture reinforces this effect. The absence of sharp edges or distinct shapes prevents attention from anchoring itself. Without highlights or shadows to follow, the visual system encounters continuity rather than segmentation. As moments pass, this evenness persists. Snowfall does not introduce new elements. It maintains the same distribution and pace. Attention responds by remaining steady, no longer adjusting itself to shifting inputs. This steadiness reduces the need for attentional effort. There is nothing to track closely and nothing to monitor for change. The environment presents information at a rate that does not exceed the capacity to observe it calmly. The snowfall does not ask for interpretation. It does not signal urgency or novelty. It simply continues. Attention aligns with this simplicity, remaining present without narrowing. Over time, the absence of focal points allows observation to feel less directional. The gaze does not settle on one flake or path. It remains spread, taking in the entire scene without emphasis. This diffusion is supported by the predictability of the pattern. Each moment resembles the last. The scene does not shift unexpectedly. Attention does not need to reassign itself. As uniform input continues, attentional switching becomes less frequent. Focus does not jump from detail to detail. It remains consistent, shaped by the environment's lack of differentiation. The snowfall maintains its even distribution. Motion remains gentle and uninterrupted. The visual field holds together as a continuous texture rather than a sequence of events. In this state, observation becomes passive rather than active. The scene does not require selection or analysis. Attention remains engaged, but without direction or hierarchy. This settling of attention arises naturally from the conditions present. It does not depend on stillness or absence, but on uniformity and repetition. Snowfall provides these elements through its steady descent. As flakes continue to fall, the field remains unchanged. No point draws focus more than another. Attention remains diffused, resting within the continuity of motion and texture, shaped quietly by a scene that offers no reason to look anywhere in particular. As the surroundings remain covered and unchanged, the environment continues to offer consistency rather than variation. Snow holds its position, surfaces look the same from one moment to the next. There are no signals indicating that something must be anticipated or corrected. The scene maintains a steady state without interruption. When sensory input is reduced and remains predictable, the body responds accordingly. Fewer changes in sound, movement, and visual contrast mean fewer signals that require rapid evaluation. Under these conditions, parasympathetic activity becomes more prominent. This shift does not require awareness or decision. It occurs as a response to stability rather than effort. Stable environments decrease sympathetic arousal. When surroundings do not present sudden changes or uncertainty, the systems responsible for rapid response are engaged less frequently. There is no need to prepare for immediate action when conditions remain consistent. The body adjusts to what is present rather than what might occur. Snow-covered surroundings provide this consistency through persistence. The surface does not fluctuate. Textures remain muted. Motion is minimal. Each moment resembles the last closely enough that prediction becomes easy. When outcomes are predictable, vigilance naturally lowers. Physiological vigilance is tied closely to uncertainty. Environments that change rapidly require constant monitoring. When changes slow or cease, the demand for readiness decreases. Snow reduces this demand by limiting variation across multiple sensory channels at once. This shift does not produce a sudden change. It develops gradually as stability continues. The longer the environment remains unchanged, the more the body aligns with that steadiness. There is no signal announcing the transition. It unfolds quietly through repetition. Snow does not create this effect by eliminating input entirely. It moderates it. Sound becomes less persistent. Visual contrast narrows. Motion becomes sparse. Together, these changes reduce the frequency with which the body must assess its surroundings. As time passes, the environment maintains its predictable state. Nothing new emerges to disrupt it. The same snow-covered surfaces remain. The same muted textures persist. The absence of surprise supports a continued reduction in sympathetic arousal. Parasympathetic activity is supported when conditions remain within known boundaries. Predictability allows physiological systems to shift away from rapid response and toward maintenance. Snow contributes to this shift by presenting a scene that remains consistent over extended periods. This adjustment does not require direction or intention. It occurs as a passive response to the environment's characteristics. Stability invites steadiness. Consistency supports balance. The body aligns with what is present. As snow continues to cover the surroundings, the environment communicates reliability through repetition. Each moment confirms the last. There is no escalation and no decline. Conditions remain within a narrow range that does not demand correction. This reliability lowers the need for physiological alertness. Systems responsible for detecting threat or urgency remain less active when change is minimal. The body remains attentive, but without heightened readiness. The snow-covered scene does not push toward inactivity. It simply removes reasons for heightened response. Without frequent changes to track, physiological vigilance diminishes naturally. Over time, this produces a softened state, not through absence, but through moderation. Sensory input continues, but at a reduced intensity. The environment remains present without provoking response. Snow supports this state by maintaining its structure. Air pockets remain intact. Surfaces remain covered. Motion remains limited. Each of these factors contributes to ongoing predictability. As long as the environment holds steady, this physiological alignment persists. The body responds to what it encounters. Snow offers consistency, and the response follows accordingly. The scene remains unchanged. Snow-covered surroundings continue to signal stability. Physiological systems adjust to this message without instruction, shaped quietly by an environment that offers continuity, low variability, and minimal demand for readiness. As snow continues to accumulate, the passage of time becomes less apparent. The surface changes, but it does so gradually, without clear markers that separate one moment from the next. There is no obvious point at which accumulation can be measured precisely. Snow arrives, settles, and blends into what is already there. Time perception depends heavily on change detection. Moments are often distinguished by events, shifts, or contrasts that signal progression. When these markers are absent or subtle, time becomes harder to segment. The environment no longer provides clear cues that separate one interval from another. Snow alters this process by reducing visible events. Accumulation happens evenly rather than in bursts. The surface appears similar from one glance to the next. Even though change is occurring, it unfolds too slowly to be tracked moment by moment. Without noticeable transitions, the passage of time feels less structured. Fewer events lead to slower perceived time. When moments are not punctuated by distinct occurrences, they blend together. The environment does not announce progression. It simply continues. Snow supports this continuity by accumulating in a way that smooths differences rather than highlighting them. Uniform environments further influence temporal awareness. When surfaces appear consistent and motion remains limited, there are fewer reference points for comparison. The scene does not reset itself repeatedly. Instead, it maintains a steady appearance, making it difficult to judge how much time has passed based on visual information alone. Snow-covered surfaces reinforce this effect through gradual change. Layers build without clear boundaries between them. There is no obvious beginning or end to the accumulation. The surface looks much the same as it did moments before, even though additional snow has settled. The absence of visible markers removes urgency from time perception. Without clear signals indicating progress, time feels less directional. It does not seem to be moving toward a specific outcome. It remains open, unfolding without pressure. This does not mean that time stops. Snow continues to fall and settle. Change continues to occur. What shifts is the ability to track that change precisely. The environment no longer offers frequent updates that would normally divide time into segments. As snow accumulates, surfaces maintain their uniformity. Variations that might indicate progression are absorbed into the overall texture. The environment does not emphasize difference. It maintains continuity. This continuity alters how time is experienced. Without frequent reference points, moments stretch. Perception does not rush to mark each change. Instead, it remains within the flow of accumulation, observing without measuring. Snow's gradual buildup reinforces this state. each layer merges with the last, reducing the sense of sequence. The environment appears steady, even as it changes. Time becomes something that passes quietly, rather than something that is tracked actively. The absence of clocks or cues within the scene supports this shift. There are no indicators urging awareness of duration. The environment does not signal deadlines or intervals. It simply persists. As snow continues to accumulate, the relationship between time and urgency loosens. Without strong markers to follow, time feels less demanding. It becomes a background condition rather than a sequence of tasks. This altered temporal awareness emerges naturally from the environment's characteristics. Uniformity, gradual change, and the absence of events combine to reshape perception. Time remains present, but it no longer presses forward insistently. Snow maintains this effect as long as accumulation continues. Surfaces remain consistent. Change remains subtle. The environment offers no reason to segment moments sharply. In this setting, time unfolds quietly. It does not announce itself. It blends into the ongoing accumulation, shaped by an environment where change is slow, uniform, and unmarked, allowing time to feel less urgent and more evenly spread across the scene. As snow continues to settle, individual forms begin to lose their separation. What once arrived as distinct crystals now overlaps and presses together, forming a shared surface. The fine details that defined each snowflake during descent become less visible as accumulation increases. When snow first reaches the ground, individual crystals may still be distinguishable. Their edges remain sharp for a short time, resting lightly atop one another. As additional snow arrives, weight increases gradually. Gravity presses layers together, and the spaces between crystals begin to close. Individual crystals lose distinction once compacted. The delicate structures that were preserved during descent are not maintained indefinitely. Compression alters their shape. Edges soften. Fine branches bend and merge with neighboring crystals. The surface becomes less a collection of separate forms and more a unified layer. Temperature plays a role in this blending. Small fluctuations encourage crystals to bond where they touch. Over time, points of contact increase. Boundaries fade as layers adjust to one another. The snowpack becomes more cohesive, responding as a whole rather than as individual pieces. Snow layers blend through both compression and temperature change. These processes are gradual and continuous. There is no moment when individuality disappears completely. Instead, distinction diminishes incrementally as layers accumulate and settle. As snow continues to fall, newer crystals join those already resting below. Each arrival contributes to the surface, adding mass rather than definition. The surface thickens. Texture smooths. Individual histories become less apparent as layers integrate. The structure becomes collective rather than individual. Snow behaves as a continuous material, spreading evenly across the ground. Variations that once existed between crystals are absorbed into the larger form. The surface responds uniformly to pressure and temperature, rather than reflecting the properties of any single flake. This transformation does not erase complexity, it redistributes it. The fine structure that once existed at the scale of individual crystals now contributes to the properties of the layer as a whole. Insulation, density, and texture emerge from collective interaction rather than individual design. As accumulation continues, the surface grows more uniform. Boundaries between layers soften. The distinction between earlier and later arrivals becomes subtle. Snow no longer presents itself as a series of events, but as a sustained condition. This process reflects what occurs naturally whenever many similar elements combine. Individual variation matters most at small scales. As scale increases, collective behavior becomes more relevant. Snow demonstrates this transition quietly, without disruption. The surface does not announce its change. It simply becomes smoother, denser, and more continuous over time. The individuality that once characterized each crystal during formation is no longer visible. What remains is the shared structure they have created together. Snow's ability to blend arises from its physical properties. Compression brings crystals into contact. Temperature allows bonding. Time allows adjustment. None of these processes require force. They proceed steadily as long as conditions remain within range. As layers continue to accumulate, the surface holds together more firmly. Movement at the scale of individual crystals becomes unlikely. The snow responds as a unified mass rather than as separate elements. This shift from individuality to continuity is gradual. There is no point at which one can say it has fully occurred. Instead, distinction fades as integration increases. The surface becomes less about the forms that arrived and more about the state they now maintain. Snow remains present, not as countless separate crystals, but as a continuous layer shaped by collective behavior. Individuality dissolves without being erased. It contributes to a surface that is defined not by difference, but by cohesion, smoothness, and shared structure, formed quietly as snow settles and remains together. Once snow has fully accumulated, the environment no longer presents itself as something in motion. The surface appears complete, continuous, and unchanged from one moment to the next. What was once a sequence of arrivals has become a sustained state. Snow no longer announces itself through falling or settling. It remains. A fully snow-covered environment behaves differently from the surfaces beneath it. Snow stabilizes surface temperature by creating a buffer between the air above and the ground below. The layer slows the exchange of heat, preventing rapid warming or cooling. Temperature changes still occur, but they unfold gradually rather than abruptly. This stabilizing effect arises from snow's insulating properties. Trapped air within the snowpack reduces energy transfer. Heat does not move quickly through the layer. The surface holds a more constant state, resisting sudden shifts that would otherwise introduce variation. The environment maintains equilibrium through persistence rather than adjustment. As a result, conditions remain consistent over time. The surface does not change in appearance or behavior from one moment to the next. Snow reflects light evenly. Textures remain muted. Motion is absent. The scene does not signal progression or interruption. Environmental consistency reduces sensory demand. When surroundings remain stable, there are fewer changes to register. The environment does not require ongoing interpretation. It presents the same information repeatedly, without escalation or decline. Snow supports this state by remaining in place. It does not fluctuate with minor changes in air movement. It does not introduce new textures or contrasts. It holds its form until conditions shift beyond a narrow range. As long as temperature and pressure remain stable, the snowpack persists. This persistence transforms snow from an event into a condition. It is no longer something that happens. It is something that is. The environment adapts around it, maintaining a steady presentation that does not demand response. The absence of visible motion reinforces this shift. Nothing moves across the surface. Nothing changes position. The environment appears paused, not because time has stopped, but because variation has diminished. The scene holds its shape. Snow's insulating effect extends beyond temperature. By moderating energy transfer, it limits the introduction of new stimuli. Surfaces beneath the snow no longer express their individual properties. Roughness, color, and texture are concealed. What remains is a uniform layer that behaves consistently across space. This uniformity simplifies perception. With fewer differences to register, sensory processing remains broad rather than focused. The environment does not present competing signals. It remains coherent, offering continuity rather than fragmentation. As time passes, this condition persists. Snow does not need to be replenished constantly to maintain its effects. Once established, it holds. The environment continues to present the same information, moment after moment. The stability created by snow reduces the need for ongoing evaluation. The surroundings do not suggest imminent change. There is no indication that something must be monitored closely. The scene remains predictable, defined by absence of variation rather than presence of activity. This predictability supports a sustained state of low demand. Sensory input continues, but without fluctuation. The environment remains legible without requiring attention to detail. The surface offers no surprises. Snow's presence reshapes the environment into a steady condition. It alters how energy moves, how surfaces behave, and how information is presented. These changes do not require active maintenance. They persist naturally as long as snow remains. The scene does not progress toward a conclusion. It does not signal resolution. It simply continues in the state it has established. Snow holds the environment in this form, maintaining consistency without effort. In this state, snow defines the surroundings more by what it prevents than by what it adds. It limits motion, reduces variation, and stabilizes conditions. The environment becomes less event-driven and more continuous. Snow remains, not as an action, but as a condition. It occupies space quietly, shaping perception through steadiness rather than change. The surface holds its form. The air remains calm. The environment stays the same from one moment to the next, defined by uniformity, insulation, and reduced demand, preparing the scene for further settling without moving toward an ending. As the snow-covered surface remains unchanged, subtle shifts continue beneath its quiet exterior. Layers that once rested lightly atop one another begin to respond to their own weight. The change is gradual, unfolding without visible movement. Snow does not collapse or compress suddenly. It settles slowly, guided by gravity acting over time. Snow compacts as layers accumulate. Each new addition adds a small amount of pressure to what lies below. This pressure is not forceful. It is steady and consistent, encouraging crystals to draw closer together. The spaces that once existed between individual flakes begin to narrow. Within fresh snow, air occupies much of the volume. Crystals rest against one another lightly, leaving pockets of trapped air between them. As weight increases, these air pockets gradually collapse. The process does not eliminate them entirely. It reduces their size and redistributes them, allowing the structure to become more cohesive. Density increases without sudden structural change. The snowpack does not fracture or shift abruptly. Instead, it adjusts incrementally. Crystals bend slightly. Contact points expand. The overall form remains continuous as internal spacing decreases. This compaction alters texture subtly. The surface may appear smoother as layers beneath it settle. Irregularities soften further as pressure evens them out. The snow becomes more unified in its behavior, responding as a layer rather than as loosely connected crystals. Gravity guides this process quietly. There is no visible descent or collapse. The effect emerges through persistence rather than motion. Snow responds to the same force that once guided its fall, now acting steadily in place. As air pockets shrink, the snowpack becomes denser. This density does not imply hardness or rigidity. It reflects closer contact between crystals rather than a change in state. The structure remains flexible, adjusting continuously to pressure distributed across its surface. The increase in density contributes to stability. Layers settle into alignment, reducing the likelihood of sudden shifts. The snow holds together more firmly, yet without resistance or strain. The process unfolds at a pace that matches the environment's overall stillness. Nothing in this transformation announces itself. The surface appears unchanged, even as internal structure evolves. Density increases quietly, supported by time rather than activity. The environment continues to present the same outward appearance while adjusting internally. This settling reinforces snow's role as a condition rather than an event. Compaction occurs simply because snow remains where it has settled. No additional input is required. The process continues as long as layers persist. As density increases, the snowpack maintains continuity. It does not segment into distinct layers easily perceived from above. Instead, it behaves as a unified mass, responding evenly to pressure across its surface. This gradual compression reduces variability within the structure. Differences between layers become less pronounced as crystals draw closer together. The snowpack becomes more uniform in density, though variation remains subtle and distributed. Air continues to move slowly through the remaining pockets. Energy transfer remains limited. The insulating properties established earlier persist even as density increases. The structure adapts without losing its essential characteristics. The surface holds steady throughout this process. There is no signal indicating completion. Compaction does not reach a final state quickly. It continues incrementally, shaped by time rather than threshold. Snow responds to gravity without urgency. Each moment contributes a small adjustment. Over extended periods, these adjustments accumulate, producing a denser, more cohesive layer that still appears unchanged from above. This increase in density supports further settling. The environment remains stable. Conditions remain consistent. Snow continues to occupy space quietly, adjusting internally while maintaining the same outward form. Nothing ends as density increases. The process does not move toward resolution. It simply continues, reinforcing the snow's presence as a sustained state shaped by gentle pressure and time, maintaining continuity without transition or conclusion. As snow continues to rest and compact, the surface beneath it becomes increasingly even. What was once shaped by small rises and shallow depressions is gradually smoothed by accumulation. Snow settles into gaps, filling spaces that once created variation. The surface adjusts quietly, guided by gravity and time rather than motion. Snow fills depressions naturally. Where the ground dips, snow collects more readily, leveling differences in height. Raised areas receive coverage as well, but the effect is most noticeable where irregularities once interrupted continuity. Over time, these variations become less pronounced as the surface equalizes. As coverage increases, surface irregularities become less defined. Sharp edges soften first. Small contours blur as snow bridges between them. The underlying form remains present, but its expression changes. Differences that once marked distinct boundaries become subtle, no longer emphasized by contrast or shadow. This process does not occur all at once. It unfolds incrementally as layers accumulate and settle. Each addition contributes slightly to smoothing, reinforcing what previous layers have already begun. The surface becomes less segmented, not because features disappear, but because transitions between them become gradual. Visual boundaries fade as coverage increases. Lines that once separated one area from another are no longer clearly visible. Snow blends these divisions, creating continuity across the surface. The eye encounters fewer abrupt changes in shape or height. The field appears more uniform, even though the underlying structure remains. Snow does not erase form. It reduces emphasis. The same ground exists beneath the surface, but its features no longer assert themselves visually. The surface presents a simplified version of what lies below, shaped by accumulation rather than alteration. As the surface smooths, contours merge. The difference between one area and the next becomes less apparent. This blending does not remove detail entirely. It distributes it across a larger area, making individual features harder to isolate. The environment responds to this smoothing by appearing more continuous. The eye no longer moves from boundary to boundary. Instead, it travels across the surface without interruption. The field holds together visually, offering fewer cues that separate one region from another. This blending extends beyond the ground itself. Snow collects along edges of existing structures, rounding corners and softening outlines. The distinction between surfaces becomes less rigid as snow bridges small gaps and overlaps edges. Over time, this effect becomes more pronounced. As accumulation persists, even larger variations are moderated. The surface approaches uniformity not through uniform depth, but through uniform expression. Differences remain, but they no longer dominate perception. Snow's ability to smooth arises from its physical properties. Loose crystals settle into spaces. Compression encourages contact. Gravity guides material downward into gaps. These processes require no intervention. They proceed steadily as long as snow remains. As boundaries fade, the surface presents fewer divisions. The environment appears simpler, not because it has lost complexity, but because complexity has been redistributed. Variation exists within continuity rather than standing apart from it. This smoothing influences how space is perceived. Without sharp transitions, the surface reads as a whole rather than as a series of parts. The eye encounters gradual change instead of abrupt difference. The process remains grounded in physical interaction. Snow fills, settles, and compresses. These actions shape the surface directly. There is no abstraction required to understand the result. The blending is visible, tangible, and incremental. As snow continues to rest, the surface holds this softened state. Boundaries do not reassert themselves unless conditions change. The environment maintains its simplified presentation, shaped by coverage rather than motion. This fading of boundaries does not signal an ending. It represents a continuation of settling already underway. Snow remains present, continuing to fill, smooth, and blend. The surface reflects this persistence through uniformity and gentle transitions. The environment does not lose its form. It expresses it differently. Snow moderates contrast, rounds edges, and connects areas that were once distinct. The result is a surface defined by continuity, where boundaries exist without standing out, shaped quietly as snow remains in place, smoothing differences and maintaining a unified field without interruption. The snow-covered scene remains unchanged. Surfaces hold their shape. The field presents the same texture and tone across its span. There is no visible motion and no area that stands apart from another. The environment does not introduce events that would draw attention or require response. The brain prioritizes detecting change. Shifts in movement, contrast, or pattern are typically registered first, guiding attention toward what is new or different. When change is minimal or absent, this prioritization has little to act upon. The environment does not supply signals that require monitoring. Fewer changes reduce attentional demand. When the scene remains consistent, attention does not need to move repeatedly from one element to another. There is no sequence to follow and no progression to track. The environment presents itself as a single, continuous state. Sustained uniform input lowers monitoring activity. Systems responsible for scanning the environment operate most actively when variation is present. In the absence of change, this activity diminishes. There is simply less information that needs to be evaluated moment by moment. The snow-covered scene provides this uniformity through persistence. Nothing enters or leaves the field. No movement interrupts the surface. The scene does not shift from one configuration to another. It holds. As time passes, the lack of events becomes more noticeable than any individual feature. The environment does not prompt the expectation that something will occur. Attention remains present, but without direction. This absence of change alters how the scene is experienced. Instead of tracking motion or anticipating difference, observation becomes broad. The eye does not search for what might happen next. It rests within what is already there. The environment does not require constant updating. The same information remains available. There is no need to check for changes that are unlikely to occur. Monitoring activity reduces naturally when there is little to monitor. Snow contributes to this state by limiting variation across the field. It smooths surfaces, reduces contrast, and eliminates small movements. The result is a scene that offers continuity rather than sequence. As the scene remains still, attention does not disengage. It remains open, receiving input without prioritization. There is no single element that claims focus. The environment does not present a hierarchy of importance. This reduction in tracking does not imply absence of awareness. The scene remains visible and present. What changes is the effort required to remain aware. With fewer changes to register, attention settles into a passive mode. The snow-covered field reinforces this state by remaining consistent. Even over extended periods, the scene does not evolve. The same patterns persist. The surface does not introduce novelty. Without novelty, the brain's change detection systems are engaged less frequently. Monitoring activity declines because the environment does not demand it. The scene remains legible without scrutiny. As uniform input continues, the expectation of change diminishes. Attention no longer prepares for difference. It remains within the present state, shaped by consistency rather than variation. The environment does not signal urgency. It does not suggest that something must be noticed quickly. The absence of events allows monitoring systems to remain quiet. Snow maintains this condition by holding the environment steady. It fills space evenly and remains in place. The surface does not fluctuate or invite interpretation. This stability allows cognitive tracking to reduce without intervention. The environment itself provides the conditions necessary for this shift. Uniformity replaces sequence. Continuity replaces event. As the scene persists unchanged, there is less to track. Attention does not need to follow movement or detect change. It remains present within a field that offers no demands, shaped by snow's ability to maintain stillness, consistency, and absence of variation across time and space. Snow remains in place across long stretches of time. The surface does not announce how long it has been there, nor does it signal how long it will remain. It simply continues, holding its form without interruption. The environment presents the same arrangement moment after moment, unchanged in any obvious way. Stable environments require less active processing. When surroundings maintain consistent conditions, there is little need to reassess or reinterpret what is present. The information available now closely matches what was available before. The environment does not demand repeated evaluation. Snow supports this stability by resisting small disturbances. Minor air movement does not alter the surface. Temperature within a narrow range does not change its appearance. The snowpack remains visually and physically consistent, reinforcing the sense of continuity. Persistence reduces prediction demands. When conditions remain steady, there is less need to anticipate what might happen next. The environment does not suggest imminent change. Expectations remain simple because outcomes remain familiar. This reduction in prediction does not arise from absence. Snow is present, visible, and tangible. What changes is the likelihood of variation. The scene does not offer cues that would require preparation for difference. The future resembles the present closely enough that prediction becomes effortless. Ongoing sameness lowers alerting responses. Systems that normally respond to sudden change or novelty engage less frequently when nothing shifts. The environment does not trigger frequent updates or recalibrations. It remains legible without heightened readiness. Snow's persistence creates this effect through duration rather than intensity. It does not overwhelm the scene. It occupies it quietly. The surface holds together, maintaining the same contours and texture over time. As moments extend, the environment does not accumulate complexity. It does not layer new events atop old ones. The same information persists, reducing the need for monitoring. Attention remains present without being drawn forward. The lack of interruption supports this state. There are no transitions to follow and no stages to anticipate. The environment does not progress toward a different configuration. It holds. This holding does not imply permanence. Snow remains as long as conditions allow. What matters here is not duration itself, but consistency within duration. As long as the environment stays within the same range, the scene continues unchanged. Stable conditions encourage sustained ease of perception. The same patterns repeat without variation. The scene does not fragment into moments that require separate attention. It remains whole. The snow-covered surface offers no urgency. It does not suggest that something must be noticed quickly. The environment does not signal escalation or decline. It remains within a narrow band of sameness. This steadiness influences how information is processed. With fewer alerts to respond to, processing remains broad and even. There is no need to prioritize one moment over another. Each moment resembles the last. The environment continues without demanding engagement. Snow holds its place. Surfaces remain covered. Boundaries stay softened. The scene does not invite interpretation beyond what is immediately visible. As time passes, this persistence becomes the defining feature. Not the arrival of snow, and not its accumulation, but its continued presence without change. The environment settles into this condition naturally. Within this stability, the mind does not need to anticipate difference. There is no suggestion that the scene will shift suddenly. Attention remains open, shaped by the reliability of what is present. Snow maintains this state quietly. It does not reinforce itself through action. It remains because it remains. The environment reflects this persistence through stillness and uniformity. Nothing concludes here. The scene does not resolve into something else. It continues unchanged, across time that is not marked by events. Snow remains present, holding the environment steady, sustaining calm through persistence rather than progression, maintaining a condition defined by sameness without signaling an end. Snow rests where it has settled. The surface shows no indication that something must happen next. There is no visible transition underway and no signal suggesting that change is approaching. The environment appears paused, not in a frozen moment, but in an extended state that continues without direction. Urgency arises from prediction and uncertainty. When outcomes are unclear or change is expected, systems remain alert, prepared to respond quickly. In environments where what comes next cannot be anticipated easily, readiness remains elevated. Snow alters this dynamic by presenting conditions that do not point toward immediate difference. A predictable environment reduces urgency signaling. When surroundings remain stable, there is less need to forecast what will happen next. The present closely resembles the near future. The environment does not prompt preparation for sudden shifts because none are suggested. Snow resting in place communicates this predictability through stillness. The surface does not evolve visibly from one moment to the next. There are no cues indicating escalation or decline. The environment offers continuity rather than sequence. Lack of immediate change lowers response readiness. When nothing in the scene suggests that action is required, systems that prepare for response become less active. Readiness does not disappear. It becomes backgrounded, maintained at a low level appropriate to the conditions. This change does not occur through absence of awareness. The environment remains visible and present. What changes is the interpretation of what is seen. Snow does not imply urgency through its behavior. It remains. The snow-covered surface does not signal deadlines or thresholds. There is no moment that appears more important than another. Each moment holds the same weight as the last. Time does not feel compressed by expectation. This evenness reduces the need to monitor for change. Prediction becomes simple because outcomes remain consistent. The surface will look the same shortly as it does now. The environment does not challenge that assumption. As stillness persists, urgency continues to diminish. Not because it is suppressed, but because it is unnecessary. The environment does not require rapid response. It does not suggest that attention must be sharpened or directed. Snow maintains this state by offering no cues that would elevate readiness. There is no movement to follow, no contrast to track, and no progression to anticipate. The environment remains legible without preparation. Predictability supports this shift naturally. When conditions remain within a narrow range, systems adjust accordingly. Readiness aligns with what is required. In this case, very little is required. The surface holds its form. Snow does not gather momentum or signal transformation. It occupies space quietly, reinforcing the absence of urgency through persistence. This absence is not emptiness. The environment remains full of texture and presence. What it lacks is demand. There is nothing that insists on immediate response. As moments pass without change, the expectation of urgency fades further. The scene does not surprise. It confirms what was already known. Snow remains in place. Urgency depends on what might happen next. In this environment, what comes next closely resembles what is already here. The difference between moments is minimal. Prediction becomes effortless. This does not imply that change is impossible. Snow rests only as long as conditions allow. What matters is that no immediate shift is indicated. The present holds steady. The environment continues to offer the same information. The surface remains covered. Boundaries stay softened. Motion does not resume. The scene remains within the same state. In this setting, urgency has no reason to persist. Readiness aligns with stability. The environment does not demand response, and so response readiness remains low. Snow continues to rest, unchanged. The scene does not move toward an outcome. It does not signal resolution or transition. It simply remains as it is, allowing urgency to recede naturally, shaped by predictability, stillness, and the absence of cues that would suggest something must happen soon. Snow forms a surface that extends without interruption. Coverage is even, spreading across space until separate areas are no longer distinguished. The surface does not draw attention to where one region ends and another begins. It presents itself as a single, continuous field. Continuous input reduces segmentation. When information remains uniform across space, perception does not divide it into separate parts as readily. The environment offers no clear markers that would encourage separation. Instead, it appears whole. Snow supports this continuity through consistent texture and tone. The surface does not alternate between contrasting features. Gradients are gentle rather than abrupt. The eye moves across the scene without encountering edges that would signal division. The brain groups uniform information together. When elements share similar properties, they are perceived collectively rather than individually. Snow's even coverage encourages this grouping by minimizing variation. What might once have been perceived as multiple surfaces becomes one extended plane. This grouping simplifies perception. Without boundaries to identify or compare, fewer distinctions are made. The scene does not present itself as a set of objects. It appears as a condition that spans the field of view. Lack of boundaries plays a central role in this effect. Boundaries create segmentation by separating one area from another. When boundaries fade, segmentation weakens. Snow reduces these separations by covering gaps, smoothing transitions, and softening outlines. As continuity increases, perception becomes less granular. The environment is no longer passed into small regions that require individual attention. Instead, it is received as a whole. The field does not ask to be broken apart. Snow maintains this state by remaining consistent. The surface does not introduce new textures or contrasts that would re-establish division. It holds its form evenly, reinforcing the perception of continuity over time. This continuity does not eliminate detail. It redistributes it. Subtle variations remain within the surface, but they no longer function as separators. They exist within the whole rather than defining parts of it. As the scene persists, the absence of interruption becomes more pronounced than any specific feature. The environment does not reset or reconfigure. It continues to present the same unified surface. Perception adapts to this presentation. Without clear divisions to track, grouping becomes automatic. The scene is taken in without effortful organization. Information arrives already integrated. Snow's even texture supports this integration. The surface reflects light evenly. Gradients change slowly. There are no sharp transitions that would pull perception into segmentation. Over time, this uniformity reinforces itself. Each moment confirms the last. The environment does not challenge the perception of continuity. It maintains it. This sustained sameness influences how space is experienced. Without interruptions, space feels extended rather than partitioned. The scene does not feel composed of parts, it feels continuous. The lack of boundaries also reduces the need for comparison. Without edges to contrast, perception does not evaluate one area against another. The scene is received without hierarchy. Snow provides these conditions through physical coverage rather than abstraction. It fills gaps, smooths surfaces, and maintains evenness. These processes shape perception directly through what is visible. As continuity persists, perception becomes quieter in its organization. Grouping happens naturally. Segmentation becomes unnecessary. The environment does not require interpretation beyond recognition of its uniform state. This soft continuity does not conclude anything. It does not signal completion. It simply continues, holding together without interruption. Snow remains present as a continuous surface. Coverage stays even. Boundaries remain softened. The scene does not fragment. It holds its unified form, shaping perception through uninterrupted input and gentle gradients, allowing continuity to persist without explanation or transition, preparing the scene for further fading without marking an end. Snow remains present without asking for attention. The surface holds its form, unchanged and continuous. Nothing within the scene shifts enough to require tracking. What is visible now closely resembles what was visible moments before. The environment does not press for engagement. It simply stays. Effort is closely associated with monitoring change. When surroundings shift frequently, processing systems remain active, checking for difference and updating predictions. In stable conditions, this monitoring becomes less necessary. The environment no longer supplies frequent signals that must be evaluated. Snow supports this stability through persistence. The surface does not rearrange itself. Texture remains even. Boundaries stay softened. There are no new elements entering the field, and no existing ones leaving it. The scene offers continuity rather than sequence. Reduced input lowers metabolic demand. When fewer changes are detected, less energy is required to process information. The environment does not call for rapid interpretation or adjustment. Processing continues, but at a lower intensity, aligned with the simplicity of what is present. This reduction is gradual. It does not occur at a single moment. As the scene remains unchanged, the need for effort diminishes incrementally. Each moment of sameness reinforces the next. The environment confirms that nothing new must be handled. Stable conditions allow passive processing. Information can be received without being actively sorted or prioritized. The scene does not require selection among competing elements. It presents itself as a whole, already organized through uniformity. Snow's passive presence encourages this mode of processing. It does not draw focus towards specific features. It does not introduce contrast that would demand attention. The surface remains legible without scrutiny. As time passes, effort becomes less apparent. Not because awareness fades, but because engagement no longer requires exertion. The environment does not ask to be interpreted repeatedly. It remains consistent enough to be taken in without adjustment. This thinning of effort does not remove explanation entirely. The scene is still perceived. Snow is still present. What changes is the intensity of processing required to remain aware of it. The environment supports awareness without effort by maintaining stability. The relationship between perception and effort shifts subtly. When change is rare, monitoring relaxes. The scene does not need to be checked continuously. It holds its form reliably. Snow maintains this reliability by resisting small disturbances. Minor variations do not alter the overall appearance. The surface absorbs them without consequence. The environment remains within the same range of presentation. As effort recedes, processing becomes more even. There are no peaks of attention followed by drops. The scene does not create moments that must be addressed. It remains steady across time. Reduced metabolic demand reflects this steadiness. Energy is conserved when there is little to update or resolve. Processing aligns with the environment's lack of variation, remaining active but unstrained. This state does not depend on withdrawal. It arises from alignment. The environment offers simplicity, and processing adjusts to match it. Snow provides a field where engagement can remain passive. The surface continues to present the same information. Coverage stays uniform. Texture does not shift. There is no need to anticipate what comes next, because what comes next resembles what is already here. As monitoring becomes less active, effort fades quietly. There is no clear boundary marking this change. It unfolds as a consequence of persistence rather than decision. The scene does not demand maintenance. Snow holds itself in place. The environment does not require correction or response. It remains stable without intervention. This stability supports passive processing over extended periods. Awareness continues without strain. The scene remains present without requiring active participation. Explanation thins as effort diminishes. There is less need to describe or analyze what is occurring. The environment explains itself through consistency. Snow remains. Nothing closes here. The scene does not conclude. It simply continues, unchanged and present. Effort fades not because it is removed, but because it is no longer required. Snow holds the environment steady, allowing processing to remain passive, sustained by reduced input, stable conditions, and the absence of change that would otherwise call for engagement, as the scene continues without interruption. Snow rests quietly, unchanged, without emphasis. The surface does not draw attention to itself. It does not shift or announce presence. It remains where it is, consistent from one moment to the next, offering no cue that something must follow. Snow persists until environmental conditions change. As long as temperature, pressure, and surrounding factors remain within a narrow range, the snowpack holds. There is no internal drive toward motion. No progression is implied. The surface stays as it is, shaped by stability rather than activity. Stable states require minimal active regulation. When conditions remain constant, little adjustment is necessary to maintain them. The environment does not need to correct itself. It simply continues. Snow reflects this principle through its quiet persistence, occupying space without requiring reinforcement. The scene remains legible without attention. The surface offers the same information continuously. Nothing new enters the field. Nothing leaves. The environment does not ask to be interpreted again. It remains understandable through sameness. Ongoing sameness supports low vigilance. When change is unlikely, readiness diminishes naturally. The environment does not signal threat or opportunity. It does not require anticipation. Snow communicates this through its lack of variation, maintaining a steady presence that does not invite response. The surface remains even. Texture stays uniform. Boundaries remain softened. The field does not fragment into events. It does not progress toward an outcome. Snow holds the environment in a sustained condition. There is no emphasis on duration. The scene does not indicate how long it has been this way, nor how long it will remain. It simply is. Snow occupies the present without extending toward future change. This persistence is not forceful. Snow does not assert itself. It rests. The environment adapts around it, not because it must, but because nothing requires adjustment. Conditions remain balanced. The absence of narrative motion becomes apparent. There is no arc unfolding, no sequence to follow. The scene does not develop, it maintains. Snow's presence reduces the need for distinction. Nothing stands out. The environment does not present hierarchy or contrast. It remains evenly distributed across space. As moments pass, the scene does not accumulate meaning. It does not build toward explanation. It remains available without requiring interpretation. Snow stays. The surface continues to offer continuity. It does not refresh itself. It does not reset. It holds its form across time that is not marked by change. This steadiness does not imply permanence. Snow remains only while conditions allow. What defines the scene is not endurance, but lack of urgency. Nothing presses forward. Low vigilance persists because there is little to monitor. The environment does not suggest that something is about to happen. Snow does not hint at transition. It rests. The field remains open and undemanding. The environment does not close itself. It does not resolve. It simply remains present. Snow holds space without instruction, without emphasis, without progression. It does not move toward an ending. It does not invite attention. It remains. The scene stays as it is. Snow rests quietly, unchanged, supported by stable conditions and ongoing sameness. Vigilance remains low. Regulation remains minimal. Nothing new is introduced. Nothing is concluded. Snow remains.